So now let's do some examples. Do you want to read them?
I can.
Yes, please.
The long solenoid S of figure has 220 turns per centimeter. Its diameter D is 3.2 centimeters. At its center, we place a 130 turn close packed coil C of diameter DC equals 2.1 centimeters. The current in the solenoid is increased from 0 to 1.5 amps at a steady rate over a period of 0.16 seconds. What is the absolute value, the magnitude that is, of the induced EMF that appears in the central coil while the current in the solenoid is being changed?
So how do we do this? So one, let's start at the beginning. I have a long solenoid with turns 220 per centimeter, which means I have to convert it to meters, which would be 220 turns per meter. Then it tells me that my D is 3.2 centimeters, which implies my R is going to be 1.6 centimeters or 1.6 times 10 to the minus 2. Then it says the inside of it, I'll put it in as the inside, small one, N has a 130 turn, closely packed coil with its diameter equal to 2.1 centimeters, which means I can write RC as 1 point something, right? So that would be 0.0105 meters. And it says that the current changes from 0 to 1.5 amps at a steady rate, and the time is going to be 0.16 seconds. So delta T is 0.16. And he's asking me, what is my induced EMF? So I'm going to walk you through the first question. Now, we know, what do we know? B field is changing. Yeah, which means there is a flux through coil C. Which means B phi flux, which we define as B dot dA, could be written as BA, since B and A are constant. And what is this A? That's the A of the inner coil. So may I write this as pi RC squared? Okay, so that's my one thing that I know. Excellent. Let me call this 1. Now, for an ideal solenoid, is B equal mu naught Ni? But in this case, I will call that N the big N because I defined it as the big N right here. Okay. Number 3. What was my Faraday's law? Actually, no, my flux law. I don't even need Faraday's law. I just need my flux law. What was my flux law? EMF N delta phi over delta t with a minus sign. But it's asking me for the magnitude, right? So I can just rewrite this as N delta phi over delta t. So far, so good. May I rewrite this as N delta over delta t b pi r c squared, or N, B is mu naught delta mu naught Ni pi RC squared divided by delta T. So far, so good. Do I have a value for N? 130 turns? Do I have a value for mu naught? Do I have a value for N? Do I have delta I? Do I have pi? Do I have RC squared divided by delta T? So what was delta I? 1.5 minus 0 amps. And what was delta T? 0.16 seconds.
Yep.
Do I literally have everything I want? I just remains the point of putting them all in, and you can calculate E with the value. The units of E will be volts, right? Because that's the push that's being given. Oh, and I calculated to be 1.2 times 10 to the minus 2, but who knows, because I may have messed up in the number of zeros I have. So I would recheck my answers.